All right, so yesterday we were looking at this Pokemon competition example, and I believe we answered number 1. Did we get to number 2? We got to, but we didn't finish it, right? Okay, how far did we get on number 2? Did we explain what C of t equals 40 means?
Yeah.
Yeah, what did we say? When Johnny has 40 cards, what day is it? Is that how far we got? Did we write an equation or anything? No. Okay, so we definitely got to do that. All right, so if you look at number 1, we said that this 3 represented a day, a time. So we were able to plug in 3 for all the t's in our equation. In number 2, though, we're saying that this 40 is representing a card value. So where would we be able to plug in 40 into our equation? Go ahead, Matt. C of t. All right, so 40 equals 1/3 t cubed minus 2t squared minus 2t plus 50. All right, now if we're plugging in a card, that means our answer would represent a day, and that's what we're trying to find, right? What day is it? So our goal eventually is to figure out what does t equal? What time or day is it? Now what's tricky about this one is we want 1t equal to something, but if you take a look at your equation, don't you have more than 1t in it? You have 3 t's showing up, but some of those t's have powers on them, which means there's more than one of them there as well. So we have t's galore. This is when it can get a little tricky to solve by hand. Okay, it might not even be possible to solve this one by hand. So this is when we're going to use our calculator to help us out. Okay, so what I want you to do is turn on your calculator. Make sure it works. Have we graphed on this equation, or have we graphed on these calculators before?
I have.
You have? Do we know, for those of us that have, do we know? Yes? You need batteries? Okay.
I don't know what I need.
Anyone else need batteries?
Actually,
Just started?
yeah.
Okay. You need batteries? Can you hit the on button? Did it not pop up?
No.
No? Okay. All right, for those of us that have graphed on these before, do you remember which buttons we used to do that? Maybe go ahead, Tyler. Y equals. Okay, so go ahead and hit the Y equals button.
I actually do need batteries.
You do need batteries. Yeah, you need batteries too. I feel like Oprah. You get batteries. You get batteries. You get batteries.
It's a recommendation at the end of the
All right, hit the Y equals button. Do you have this screen that pops up?
Yep.
Perfect. Do you have things typed on it, in it? Some of you might, some of you might not. If you have anything typed in there, you can go ahead and hit the clear button to delete it. You can also use the arrow buttons to move that cursor to the different rows and clear those out as well. So make sure you clear out anything that's in there. Okay? So what we're going to do to help us answer this question, on which day did he have 40 cards, we're going to graph this equation that we wrote down. Now, this equation has 2 different sides to it, okay, 2 different parts. We're going to graph the 40 in y1. Okay, that just means we're going to represent it as our first equation. And then we're going to take the other side and type that in y2. Okay. Is that bright enough? Can we see that on the board? Yeah.
battery has to
Isn't really. All right, so in Y1, go ahead and type in 40. All right, go ahead and arrow down to Y2. We're now going to type in the other side that has all the t's and things in it. Okay, now when it comes to your calculator, typing in a fraction can get a little tricky. I think I heard someone kind of explaining it. Go ahead, Nathan. Or, oh, that was her. What's her name?
Harley.
Harley. Thank you. Okay, Harley, how did you do it? Do you know?
I just put in like 1 divided by 3 and then hit math and then fraction.
Okay. Let me try that real quick. 1 divided by 3, math. Oh, I know what you're doing. Okay, that's one way to do it on like a regular calculator screen to turn it into a fraction. We're going to graph this though. So in terms of fractions, I need you to put the 1 divided by 3 in parentheses to kind of separate it from the variable. That way the calculator knows it's a coefficient and it doesn't really put the x in the denominator with a 3. So type in 1 divided by 3 but put it in parentheses on both sides. Okay? Now in our equation we have t's. Okay, but I think we said yesterday those t's really represent x's, right? Our x button is towards the top, right next to the alpha green button. So go ahead and hit that to bring up your x. Now we need to somehow bring up a power or exponent of 3. Do we know how to do that? Good, Helen? All right, so this, it's towards the bottom on the screen up there, but right underneath the clear button, you have that little arrow. It's called a caret. You press that. I do too. Now, here's the thing. Depending on the operating system or model of your calculator, yours might look a little different. The newer operator systems will put in that box, okay? The older operating systems use the caret. It doesn't have that capability of making that box, okay? So on this one, we're just going to type in 3. Now what you need to be careful with, if you have that box, do you see how the cursor has a little arrow in it pointing to the right? You have to make sure you use the right arrow to bring the cursor back down. Because if you didn't and you continued typing, everything would show up in the exponent spot. And that really wouldn't be nice. Okay? So you got to make sure you arrow back over. If we continue through the equation, we have minus 2. Hello? Hey. Sure, no problem. Yep. Bye. Mackenzie, they want to see your guidance, okay? Right. She's fine. All right, next we have another t, which means in our calculator we're going to use an x. How can we get a power of 2? You could do it the same way we did the 3, but there's actually a shortcut button. X2, yep, right there. Okay, it's above the log button on the left-hand side. That button automatically gives you a power of 2 without having to hit that caret arrow button. If we continue through, minus 2x, and then plus 50. We doing okay? All right, do me a favor and go ahead and hit graph. There's our straight line. Does yours look a little different than mine? What's up, Josh? We're going to talk about it. Okay, we're going to talk about it. We're going to talk about it, yep. All right, so all of us have the same thing typed in, right? But we all have a different picture, okay? What's causing that is the window. Okay, just like a window at home or at school, okay? A window is what allows you to see something, like see outside. So I want you to go ahead and hit the window button for a second. Now if you were to compare your window to maybe your neighbor's, they might be a little different, okay? What the window does is it's a way for you to program or tell the calculator what you want the x-axis to be, like how far left and right you want to go, and then what you want the y-axis to be, how far up and down you want to go. So we're going to make all of our windows the same, that way we can all see the same picture. Okay? Now, the x's in our problem, we said represented days. What do you think the x minimum, or the lowest amount of days might be for this Pokemon tournament? 0. Maybe they had to cancel it. Maybe it didn't even happen. So we're going to let the x min be 0. Do we know the longest amount of days this Pokemon tournament might last? 7. Perfect. Okay, so there's our minimum x value and our highest x value. Now the x scale represents the tick marks, like what you want to count by. So if you're going from 0 to 7, do you want to count by 1s? Do you want to count by 2s? Count by halves? You can count by anything. You can choose whatever you want. You want to do 1s? Okay. So if we go from 0 to 7, we'd have 7 tick marks. That seems like enough, right? All right, so the y's, on the other hand, are representing the amount of cards throughout this tournament. So what do you think the lowest amount of cards might be for Johnny? He might lose all of them, right? It could be 0. But negative doesn't make sense. Okay? What do you think the highest amount of cards might be? We're not really sure, so this is when we kind of take a guess. We can always change it. 100, yeah? 50? Okay, try either one of those. It doesn't matter. Maybe we'll try 100, okay? So we're going from 0 to 100 on the y-axis. What do you want to count by? 1s, 5s, 10s, 20s? Doesn't matter. 5s, 10s, you choose. Okay, whatever you feel comfortable with. All right? All right. Doesn't the graph now look a little better than what it did previously when you initially hit it? Okay, it's because we changed the window. It makes more sense for this problem. So on this picture, the flat straight line is the 40, okay, a constant equation, whereas the curve is the equation with the t's in it. So if we're trying to figure out when does the curvy graph equal the straight graph, okay, when are they exactly the same, where do you think we're looking at on this picture, on this graph? Can you describe it? When are they the same? I heard it. Say it again. 240? What do you mean by 240? X equals 2, so somewhere right here, right? Yeah. X is 2, y is 40, what's that called? X-intercept is where it's y-intercept crosses here. What's it called when they cross each other? Point of intersection. All right, we're looking for points of intersection. Okay, so let's go ahead and see if we can figure out those points exactly. So, guys, Isaiah said that it kind of looks like 2, 40, but let's see if we can get a little bit more accurate, okay? I want you to hit the trace button at the very top. You should have a little cursor. Sometimes I call it a spider because it has those little legs on it. And you can use the arrow keys to move it across your graph. All right, so Isaiah was pretty close. Doesn't it look like the intersection's close to 2, 40? We're going to find it exactly. Okay, we're not going to guess it. We're going to let the calculator do the work for us. Get it exactly. Okay, so we initially hit the trace button to bring up the cursor, but what we're going to do now is go to the calc menu right above that trace. Do you see how the calc is in blue? That means you have to hit the blue second button first. So if you hit the second button and then trace, it'll bring up that calculate menu. The reason we have that second button is because it gives us a way that this trace button can be used 2 different ways. So instead of having a bunch of buttons to have to press, this simplifies that process. Okay? Which option in this calculate menu do you think we're going to use? Intersect. So let's go ahead and scroll down to number 5 and go ahead and hit enter. So what I want you to do is move that spider to where you think the intersection point is and hit enter 3 times. Can we all get the same x value? 2.111 or something really close to that? Okay, so there's one time where he has 40 cards, a little bit after the second day of the tournament. Okay, do we have another time though somewhere? Yeah, don't we have another intersection point? So we're going to repeat the process. Okay, you have to hit the second button, then the trace to bring up that calculate menu. We're going to choose option 5, and we're going to move the cursor to where we think it is. How many times do you hit enter? 3. All right, so there are 2 points during this tournament where he had 40 cards. A little bit after the second day and then a little bit after the 6th day. Do you realize how those values would have been a little bit difficult to figure out by hand because they're very long decimal values? Okay, we're going to let the calculator kind of do the work for us on that. We doing okay so far? Am I going too fast? All right, let's check out number 3. What does the y-intercept represent? Okay, so we kind of mentioned this idea earlier when we were trying to say intersection point, but what does the y-intercept represent? Good, Matt? How many cards he had at the beginning, okay? So our y-intercept is where the curvy graph crosses the y-axis. That's representing a time of 0, okay, an x value of 0. So we'll say the y-intercept represents the initial amount of cards. Okay, how many cards Johnny started with? Now maybe you can tell based off the graph what that number is. Maybe we can use the actual equation to help us with that. If we're looking for the initial amount, what's the time associated with an initial or beginning amount? The moment you walk in the door. I heard it, Aiden? 0. Okay, so if we were to plug in 0 into this equation for all those t's, what would we get out? Can you think about it real quick? If all the t's are 0, they're going to go away. We're left with 50, right? That constant number on the end. So the initial amount of starting cards was 50. Perfect. All right, and you can kind of tell based off of your graph, if you counted up your tick marks, whatever they represent, the 5s or the 10s, whatever you used, it would be that 50 amount. Okay? All right, let's check out 4. What is the lowest amount of cards that Johnny had? All right, this is another calculator one because we have a picture of it. Can you somehow describe where the lowest amount of cards might be? Can you tell based off of our picture? Harley, I saw your head shake. Go ahead. The lowest point of the y value. Okay, so probably somewhere right there, right? That little dip. Okay, so let's go ahead and hit our trace button and see if we can get the little spider cursor to go there. What's our issue? It's on the wrong graph, right? It's on the straight line and we need it to be on the curved line. So if you want to make that little spider dude jump from graph to graph, you have to use the up or down arrow. So I don't care which one you hit, it'll move it to the other graph. All right, so if we try to guess where it is, maybe somewhere right there. But again, we're going to let the calculator do the work and it's going to find it for us exactly. Okay? So we're going to go back to that calculate menu. Do you remember how to get there? what buttons we press? Second, and then that trace button. Which option are we going to use now? Minimum, right? We're trying to find the lowest point or the minimum. Now this is a little different than the intersection. Okay, intersection's easy because you just hit enter 3 times. This one we actually have to answer some questions first. Do you notice how towards the bottom it says left bound? Okay, what that's asking you to do is pick a point to the left of where you think that lowest value is located. So I'm going to have to move my cursor again to get to the actual curve I want. Okay, hit the up or down arrow. And if I think the minimum is right there, I'm going to hit the left arrow a few times. I don't care. You could do it once, you could do it twice, you could do it 5 times. Just go a little bit to the left. I now want you to hit enter. Did you see that little arrow kind of pop up towards the top? Okay. What we're doing is we're making it easier for the calculator. Instead of the calculator having to check the whole graph for the lowest point, we're just letting it check a certain section. Okay, it'll make it go quicker for us. Notice how the next question says right bound. So we're going to move the little spider back to where we think the lowest point is, but now we're going to go a little bit to the right. Hit the right arrow a few times and hit enter. Okay, that other arrow should pop up on your screen. So you're telling the calculator, I don't want you to check everywhere, I just want you to check in here. Okay, it's going to make it quicker. Notice how the last question is where you think it is. So we'll go back and just hit enter. Now that the screen says minimum, okay, that is the lowest point according to that condensed section you gave the calculator. Do we all have the same number roughly? Okay, so let's go ahead and write that down. The minimum, let's see, it happens at the point 4.449 and 30.869. Okay, we'll go to 3 decimal places. All right, so now that we found the lowest point, let's make sure we can actually use it to appropriately answer this question. What is the lowest amount of cards that Johnny had? We got 2 numbers up there. Which one means cards? The 30, right? This was a time, aka an X value, and this was a card, aka a Y value. So we can say Johnny had the least cards, 30.869. Do we know when he had the lowest cards? A little bit halfway through the 4th day, okay, 4.449. So Johnny had the least cards, 30.869, on day 4.449. We're doing okay? Calculator not too bad? All right. Let's go ahead and try another one. Go ahead and flip to the back. So this one's very similar. It's just in this case, instead of a Pokemon tournament, we're having a 1-day layover in Vegas. I think I'd rather be there right now. Okay. Do you want to try this on your own with the calculator, or do we want to do it together? Alone? Together? How about you two work together? Okay. I can come over and help, okay? I want you to try it, okay? Play around with the calculator, see what you can do. Use the example we just did as a guide, okay? I'll be around if you need help. Don't be afraid to ask. Mostly has everything else Just as a heads up, when you get to the calculator part, like actually having to graph it, this is a different scenario than the Pokemon one, right? So you may have to change the window for it to make sense for this graph. Don't be afraid to play around with those window numbers.
Yeah, for sure.
Yeah.
There's a nice one in the back.
You got negative 6. You get that?
What's happening here is if you starting amount, you were telling me you were so that's your one, right? So she started from 18, but when she except this is total. That's so what this is meaning is not only did she lose almost 180, but she had to go back more money than she scratched.
Told you.
So she had less money until she got rid of it. So she initially started right?
So she lost all the answer.
She lost all of that, and she lost that much more.
So she lost her
Yes. You can say she
she's $6.72. Right? Because if she loses 180, she's back to even. But you could say that she's whole because she lost that much money.
Oh boy, she crashed hard.
That's not good.
Oh my. So halfway through the entire series, she lost all of her.
How much do you want for That's the most.
I'm saying we can't see it. So we change the one that gotta change it. Just so I know what's going
Calculator help anybody? I like how you make this right. Your x's are in the time, and your lots are in the So, what is the least amount of time? Oh my gosh. What's the most amount of time?
Okay, still on there must be something.
So, how many levels?
Till 5.
Okay. This is 12. Over 12. So, what's her only there for 1 day?
Oh yeah.
So then for y is what's the least amount so they're negative, right? So maybe we'll choose negative.
I saw it along. So I see you just on.
I think it's already drafted.
It started with 100.
You're saying the lowest number is negative. Or delete gets rid of the single item. So what do you want the lowest Yeah, no, that wasn't.
So when you find the excellent. Okay, I found Alright, second. Wait, you were trying to find me
I got it. 11. Well, I don't know what I'm doing, but.
If you ran out of money halfway through.
Yep, and you have it where you think it's right.
That's why you don't gamble, kid. Went bankrupt on someone's house and should have sold it. I think for a bill,
I'll send it with my dad, but I gave him money to
Now, figure out, this is a class. We need to hit second and then trade. And choose the second option. And now that you have the first break, it is, it just Alright guys, bell's gonna ring in a little bit. Try to finish up the question you're on if you're using a calculator. We'll pick up with this tomorrow and we'll check all of our answers, okay?
You want to see these papers?
You should be like this. Okay. And now that we did a few of them. If you have one of Try some of the homework problems tonight. You gotta keep up with them.